All right, here we go.
All righty. It is. All right. Okay. Hello, everybody. Welcome to Science at Home. We'll give folks just a minute to kind of get situated before we start. Let's see. Okay. See if we get any other attendees for us on this snowy Tuesday, or at least snowy in Boulder.
Oh yeah.
Is it snowy? Twila, is it snowy where you are?
We have some snow on the ground, but it's not actively snowing.
Okay. Yeah, no, it's not actively snowing here either. We just, is it? Ms. Stewart's class, is it snowing where you guys are? Maybe. All right, so let's go ahead and get started. Welcome, all of you homebound scientists, and greetings from Boulder, Colorado. My name is Erin Leckie, and Amanda Morton and I are, as I guess not always, as occasionally, your hosts for Science at Home from the Cooperative Institute for Research in Environmental Sciences at the University of Colorado. And our guest for today is Twila Moon, who is a researcher at Ceres, and she's going to speak with us about her work on ice dynamics today. So how did Twila get into studying ice dynamics, you are asking yourselves? Well, Twila decided that she wanted to study ice and glaciers when she got a chance to go to Nepal as a sophomore in college and do some work in the Himalayas, or Himalayas as some people pronounce them. Maybe she can help us figure out which of those is the actual correct way to pronounce them. But these are some of the tallest peaks in the whole wide world. And when she was up there, being surrounded by all of the sounds of the mountains, the melt water and the rocks falling, it sounded like the mountains were alive, and she became totally captivated with it. And so when she got back to her university, she asked her advisor, how do I go about studying glaciers? Like, is that a thing? How do I do it? And her advisor, even though they didn't have someone who's a glaciologist there at her university, said, you need a bunch of math and physics. So she did it. And now she's on the path that she is today. So today, she's going to be sharing her work with us. And as always, you can put questions into the Q&A, and we will answer them at the end and pull them all together for you. So with that, take it away, Twila.
Great. Thanks so much, Erin, and hello to folks all over. I'm super excited to connect with you. And Erin, I'm going to depend on you to interrupt me with questions or other things, because I can see my slides, but I can't see all of the audience.
You got it.
So we are going to start by orienting ourselves and where we are. And this map shows us where ice is all over the planet. And all of the blue are the world's smaller glaciers and ice fields and ice caps. And the place I was first discovering ice was over here in the Himalaya. And I think it's okay to have more than one pronunciation. But I now spend much of my time thinking about Greenland. So we have all of this smaller ice in blue, but we have our big ice sheets. Antarctica, of course, being a continent here in the southern pole, and Greenland, the largest island in the world. So as we zoom into Greenland, you can see here we have ice sitting on land beneath it, right? So this is all ice that's made out of fresh water, and you can see the landscape kind of peeking out around the edges of the ice sheet. And these is the areas around the edges that the roughly 60,000 people who live in Greenland, where they have their towns and communities. But it's hard to get an idea of how big Greenland is without considering how deep that ice is too, and how thick it is. So if we could imagine ourselves drilling down into the ice sheet here, we would find that the thickest parts of the ice sheet are about 2 miles thick. So you can imagine piling one on top of each other 7 Empire State Buildings, from the ground to the very tip of those towers on top. and that's how thick much of the Greenland ice sheet is. The Greenland ice sheet is essentially doing us a service all around the globe by holding this water as ice that would otherwise be in our oceans. But if we were to actually melt all of that ice that we have in Greenland, our oceans around the globe would rise by about 7.4 meters or about 24 feet. So we're very thankful for the Greenland ice sheet doing a good job of holding our ocean waters as ice. It can still be hard to get a sense of the scale of the Greenland ice sheet here. So we're going to go ahead and zoom into, if I can get my advancer to work. Sorry, I'm running into my little technical difficulties here. Let's see. Uh-oh. Hold on. Uh-oh. Erin, can you still hear me?
Yeah, I can totally hear you. And we can still see the slide with the Empire State Building on it, but
my computer is not
kind of frozen.
Well, it's not allowing. Yes, exactly. It is freezing. Ah, phew. Okay. Well, at least at minimum it unfroze itself. So let's dive back in and see if we have any success.
Okay, super. It's okay. That happens a lot. So no worries. Everyone is very cash.
Thanks, guys. I appreciate your understanding. All right. Phew. We're back to thinking about Greenland, and it's time for us to zoom in and get a sense of what this might be like on the ground. So we're taking this Greenland ice sheet and we're going to zoom in here to a very famous glacier in Greenland called, it's been called by the Western name of Jakobshavn, but the Greenlandic name is Surmet-Kujalek. And I've been trying hard to become better at using that Greenlandic name. So if we were to move in to this little teeny place, it's kind of barely a pixel on my screen, and we were looking at it from a helicopter, it would look something like this. And we can see here the edge of this glacier. So this is the very end of it. We're looking back towards the interior of the ice sheet. And then out here in front of the glacier is essentially ocean water, but you can see that it's entirely covered with icebergs and bergy bits, which is actually a technical science term for smaller icebergs. But still, looking at this picture, I know I'm left with a question of how big is that? So again, we've got to pull out some comparisons. So the first comparison here, the ice that we see actually sticking up above the surface of the ocean here is about 100 meters or 300 feet tall. So the height of the Statue of Liberty from ground to the tip of her torch. Now, ice, as you know, if you put an ice cube in your glass of water, most of it is down below the surface of the water. And the same is true of this glacier. So what we can't see is another 900 meters, almost 3,000 feet of ice front that is hidden here below the surface of the ocean. So we have a very big end of a glacier. And then if we were trying to understand how big this is across, we're looking at about half the width of this glacier. And many of you might be familiar yourself or someone in your family of participating in a 5K walk or a 5K run. That's often kind of like the community event length. Well, imagine walking in a straight line for more than 3 miles, and you will have maybe just gotten across this portion of Surmet-Kujalek. So even though on this map, it looks like we must be zooming into a very, very small place, you can see that once we're there, it's actually really big amounts of ice. And we're dealing with phenomenally large landscapes that can be pretty hard to imagine. Now you can appreciate if we were trying to understand how the Greenland ice sheet was changing and we were always just looking at it from the ground or from a helicopter, we can't see very much of it at once. So science for understanding the Greenland ice sheet and how it's changing was revolutionized by satellites. So much of what we understand about Earth's ice, we can thank satellites for helping us to understand. And they're allowing us now to ask questions about how the whole ice sheet is changing and things on all of the coasts. So now we can ask important questions like, how is the edge of the ice changing? And as I promised, we're going to continue to keep revisiting this glacier on the west coast, Surmet-Kujalleq. And so how did the ice edge there change? Here, we're zooming into another picture from space. There's actually a town that's down here. This is a World Heritage Site. And you can see these lines are showing us where the edge of this ice has been over time. Since this is a populated area, we have some idea of things further back in time. But you can see through the 1930s, 50s, and up through really the 90s, this glacier came and ended in this area. But since 2000, we've seen a really rapid retreat of this ice. So the ice is flowing in here from the right, but where that ice ends keeps moving further and further inland. And you can see, for example, it means that we're exposing new land that has never in recent history been exposed, and we're seeing new lakes and waters, and all around the edge of the ice sheet it's retreating. I have one other story about seeing the edge of the ice retreat. This is a picture from fieldwork I was doing in Northwest Greenland a few years ago with this team of scientists understanding how narwhal whales use the glacial environment. And we were working off of this research ship, which looks very small in this big landscape. It's actually about 100 feet long. It was very comfortable for 16 of us to be living and working on. And one day I was up talking to the ship's captain, and I looked over his shoulder, and this is the map he was looking at. Here was our boat. This orange was supposed to be showing him where the edge of the land and the ice was. And as you can see, this map said that our boat should have been essentially boating around on the top of the ice sheet. But when I looked out, this was the scene in front of me. So we're seeing truly uncharted waters opening up all around the edge of the Greenland ice sheet. As that edge, we can also ask questions about how the ice moves. So a distinguishing feature of glaciers is that they move. And you heard Erin tell you how I myself was super captivated by kind of the action of ice and glaciers. And you can think of them like slow moving rivers. This map, thanks to satellites, we can see how ice is moving all around the ice sheet. And here in these lighter colored interior areas, the ice is not moving very fast, maybe just a couple feet per year. But as the ice approaches the edge and we get towards these glaciers that connect to the ocean, the speed of the ice really increases. And Surmet-Kujalleq, that glacier we've been looking at, it can move on the order of 16 kilometers per year. So that's something, I don't know if I have that math right in my head, maybe somewhere around 10 miles per year of moving ice through it. And if we zoom in to an area, you can again see, we can't think of the ice sheet as kind of a stagnant, moving body of ice. In fact, it's flowing and moving, and we're getting these streams of ice moving from the interior out to the ocean. And that's where they're able to move ice out to the ocean and drop it off as big icebergs, or it melts at the edge as it contacts the ocean. And so because we have been looking at the ice sheet with satellites now for a few decades, we're able to see the changes happening there, and we've seen that the edge of the ice sheet is being reconfigured really quickly. This is that Surmet-Kujalleq glacier, and here you can see areas in red where the ice is speeding up and areas in blue where the ice is slowing down. And so when this glacier ended out here, it probably looked mostly like one red streak. But now we can see that maybe that glacier is starting to actually split and become multiple glaciers. Or up in this area where we're continuing to move ice through this glacier, but it's really slowing down here. So the configuration of the entire edge of the ice sheet has been changing really rapidly just over the last 10, 20 years. We can also ask questions about how much ice there is in total. You know, what is that total volume, that total mass? And again, satellites play a key role. There's more than one way that we ask this question, but one of the really cool ways we ask it is with a pair of satellites called the Gravity Recovery and Climate Experiment. We're actually now in our second pair of satellites. So there was a pair up, they did their job, but these instruments don't last forever, and now we're on our second pair. And these satellites work together to measure the amount of ice on the Earth's surface. So they can measure it so accurately that they can tell us how much ice we're losing or gaining throughout the year. And before we talk about how much ice we're losing, I'm going to be talking to you about it and showing you an image that's showing how much ice we're lost measured in gigatons. Gigatons is not a normal unit of measurement that we talk about day to day. 1 gigaton is 1 billion tons. And that includes about as much water as it takes to fill 400,000 Olympic swimming pools. And I'm showing you here on the screen what it looks like if we put 3 1 gigaton blocks on Manhattan Island. And you can see here's the Empire State Building again. Here's 1 gigaton. And you can appreciate how big and tall it is. So I'm going to be actually talking to you in measurements of thousands of gigatons. So we can appreciate we're talking really big numbers. What does it look like around Greenland? Well, this is data that was collected by our first set of those satellites. And first, let's look here. What you can see is we gain ice during winter when there's snow falling, and we lose ice during summer when we have melt happen. So that's why we have this up and down of this graph, because we gain ice during winter and we lose it during summer. And then over on this side, we can see where we're losing that ice over the ice sheet. I'm going to play it once more because I think it's really neat. Here we have these lines that can show you how the ice is moving. So again, you can appreciate that the Greenland ice sheet is not stagnant. It's really moving, some places very rapidly. And these colors, these darker colors are showing us where we're losing ice from the ice sheet. And you can see that we primarily lose ice all around the edge, and some areas like our area here near Surmek-Kujalek that we've been looking at is an area where we are especially losing a lot of ice. But today we're at a point where we're losing ice all around the edge of the ice sheet, and we can measure it really precisely from space. We can also ask questions about why we're losing ice. And I'm going to highlight 2 different ways in which two reasons kind of why we're losing more ice than we used to. One of those has to do with our warming atmosphere. So we know people are putting carbon dioxide and methane and other polluting gases in the atmosphere. That means that we're able to hold more heat in our atmosphere and we have warmer temperatures. Now, if we look at the surface of the ice sheet, so again, we're looking down from space. Here's Surmek-Kujalek. Here's the land at the edge of the ice sheet. And this is all the ice sheet itself. And what you can see here is that in the interior, we have this bright white snow. And that bright white color allows us to more easily reflect radiation and heat back out to space. In contrast, here around the edge of the ice sheet, we've melted away last year's snow, and we're exposing darker glacial ice. So you can see it's a darker surface, and we also have these small dark dots. Those are actually lakes of liquid water on top of the ice sheet. And all of this dark surface, just like wearing a black t-shirt outside, that dark surface is good at capturing radiation and heat from the sun. So today, as we have warmer temperatures in the atmosphere, we are more easily melting the surface of the ice sheet, exposing this dark surface and capturing more heat. So it creates an amplifying loop of surface melt. Another reason that we are seeing more ice loss than we have before is we're also warming some of our ocean waters. And interestingly, we're not just warming the waters at the surface, and sometimes we're not warming the waters at the surface at all, but we're warming waters that are deeper down in the water column. And those waters can get down here, and they aren't accessing this ice that we see. They're accessing that ice that we can't see, that's hidden below the ocean surface. And that warm ocean water is more rapidly melting the ice beneath the surface. Oh, I have a kitty visitor now too. Melting the ice beneath the surface and encouraging glacial retreat. So why does it matter? And I'm guessing that you guys have a few ideas. So I'd be curious, Erin, if anyone wants to put a few ideas about why it matters into the chat, and see if any ideas come up before I give a few ideas about why it matters.
Excellent idea. Let's put it in the Q&A. Why does it matter that we're losing this ice? Come on, don't be shy.
You can think about why it matters for people close to Greenland or people far from Greenland.
Maybe it's still too early in the day. People are being very shy.
All right. Okay, well, then I'll go ahead and fill in some of these question marks. So the changes in Greenland, they do have influences that stretch from the local to the global. So locally, as we're losing ice, just as I showed you, we're opening up new ocean and fjord waters that have never been open before. And as we melt the ice, we're adding more cold, fresh water to the ocean. That changes the ecosystem for plants and animals there, and it changes what people there are experiencing. For example, when I was in Northwest Greenland, we met with these indigenous hunters. They were out on a narwhal hunt, and they described to us how they have seen really rapid changes in their environment that has changed the way that they have to hunt and fish. It's changed the behavior of animals, and it's changed their ability to travel and connect with people in other towns and locations. When we think about changes on regional scales, as we add cold, fresh water to the ocean, remember the ocean is full of warmer, saltier water, and we're adding this different thing to it, and that influences how the ocean currents move. So all these lines on here are showing you kind of how water moves around the ocean, and as we're putting more different water into the ocean, we're influencing how the ocean water moves, and that can affect climate, for example, in Europe or in the US. And if we're thinking about changes on the global scale, we're starting to appreciate that if we contain ice within Greenland and Antarctica, and it's acting as that global water tower to hold ice for us instead of putting that water into the ocean, if we're losing the ice, we're adding ocean water. And that's the kind of effects that we can see on coasts all over the world. As we increase sea levels, we can see more coastal erosion. We can also, because the water in the ocean is salty, we can have salty water starting to get into our freshwater drinking sources. And it can be harder for our sewage and waste management systems to work properly. We can also see flooding happening in areas where it's never happened before, or it can happen more often in areas that have seen it before and higher levels of flooding. So that is a really important impact that changes in Greenland have all around the globe, affecting billions of people and certainly affecting us here in the US. These are all pictures from the US East Coast. So the Greenland ice sheet has been losing ice every year now since 1998, and that amount of ice has been over time overall increasing. We saw a new record of ice loss set in 2019. So that's pretty difficult news to take. We're seeing rapid changes, and we can see that they're influencing people and animals and plants, as well as communities and our infrastructure and economies all around the globe. But I also have what I consider really good news, which is the biggest predictor of the future of the Greenland ice sheet is, in fact, us people. This isn't changes that are happening that are out of our control. And we've done some really cool work in the science community to make computer simulations of what might happen in the future. So this is a computer simulation looking into the future of the Greenland ice sheet. And we're looking at 3 different possible scenarios of the future. These are scenarios that are also used by the Intergovernmental Panel on Climate Change, which is a partnership of countries across the globe, many dozens, who are all coming together to understand how climate change is influencing the planet. And they spend time thinking about a future in which, on one hand, we collectively as a globe take really aggressive action to act on climate change and to reduce the amount of warming in the future. Then there's a scenario where there's a medium amount of action. And then there's a scenario where our future looks a lot like the past 10 years, where we're putting substantial amounts of carbon dioxide and methane into the atmosphere. And they're then looking at what this is going to mean for the ice sheet over the next 1,000 years. So ice sheets they respond to many years of what we humans have been doing. And I'm going to play this again because I think it's incredible to see that if we as a globe were to take strong action on climate change over the next decade, in 1,000 years, we're going to have most of the Greenland ice sheet in place still. That's in really stark contrast to if we continue on a path that looks like putting a lot of carbon dioxide and methane into the atmosphere and not doing much to address climate, we might actually lose the entire Greenland ice sheet in the next 1,000 years. And I'll remind you, the Greenland ice sheet it's had ice there for hundreds of thousands of years. So this would be very, very quick change. And the thing that happens is in any of these scenarios, we're not stopping the seas from rising, but we're really slowing it down. And that is good news because that gives our communities and our economies and our governments and businesses and us as individuals a lot more time to adjust to increasing sea level. So us people are very much the ones in charge of thinking about the future of the Greenland ice sheet. And I think that's a really incredible area of opportunity for us to really create the future that we're going to see and help our communities have a better timeline for dealing with sea level rise and also the other changes that happen as we lose ice in Greenland. So that's the content that I have for you guys already prepared. And I will go ahead and turn it over to Erin to see about any questions that have come up.
Yeah, thank you so much, Twila. That was awesome. And I have to say that I was making a list of questions for myself, and you answered like all of them. Okay, I had several questions that just as soon as you mentioned narwhals. So that was awesome. So I'll try and synthesize what we've got going there right now while other people have a chance to kind of collect their thoughts and put some more questions in there. And so one of the questions that's sort of on a larger scale is that, so Greenland has had ice on it for a really long time. And so losing that ice is going to have changes for Greenland. And you talked about some of these. Are there, how long has this change been happening, and how long do you think it would take things living on Greenland to adapt to the new regime of icelessness?
Yeah, well, we can see that the kinds of changes that we see happening now, so changes that are very rapid and that are happening all around the coast of the ice sheet, those have been particularly intense over the last 20 years. So the Greenland ice sheet was not changing much in the 1960s, the 1970s, the 1980s, even the early 1990s. The changes that we see today really started to happen in the mid 1990s, and the rate of change has been increasing. So that's where we get to that kind of number that I shared, where the ice sheet has now lost ice every year since 1998. And I could appreciate in getting to meet the people who are living in Greenland and who are dealing with those changes directly, that they've really felt the dramatic changes over the last 10 to 20 years. And they've had to adjust the way that they hunt, adjust the way they fish, adjust the way that they travel in winter. For example, winter sea ice is often how they travel over the sea ice to get from one place to another to visit relatives. And that has become more difficult. And they've seen how animals are also changing their behavior. And they see polar bears in places that they haven't before and doing things that aren't familiar to them. And I want to emphasize that the indigenous people living in Greenland, they have a really awareness of the patterns of nature that is much, much deeper than most of us have of our local environment. They live in a culture that they are passing down orally spoken information about the environment and how it works there, where animals travel, when they travel, those sorts of things. And they've been able to kind of retain that information over thousands of years. And they are now suddenly seeing an environment that doesn't align with what they've been seeing over those thousands of years. And they are really having to adapt in the moment to those changes that are occurring.
Yeah, I'm just thinking about the people on this call. So some of us are in Colorado, so not close at all to coastlines, but there's folks on the call who are from New York and from other coastal areas, and so I imagine that having to suddenly adapt to many more gigatons of water and a much higher sea level is something that people on the coastlines are particularly worried about. But since my background is in geology and paleontology, it wasn't to me all that long ago that Colorado was underwater. We have clam pops from Colorado. So even though the topography has changed now, it's not just the coastlines that this is a problem for. And go ahead.
Well, I really agree with that. Your point about anyone in the audience who's been doing a little bit of studying of geology and getting a sense of geologic time can appreciate that the changes happening now are truly happening in the blink of an eye. As far as what normally happens with natural changes in the Earth system. But also this point about how sea level affects people, I think it's important that we recognize that today we live in a connected global system. So lots of our coasts we use for security, setting up military bases. It's where we have shipping ports. So you're getting goods that shipped here over the ocean. I'm speaking to you from Montana, and I get goods here that probably traveled by ship over an ocean and then by land, over land by a train. And similarly, our coastal communities that are having to deal with flooding and really challenges for infrastructure like drinking water, those can be very difficult, and often we have to provide resources, human, volunteer, financial, that require input from states here across the U.S. So we're assisting the federal government to help these people locally. So it's really something that we are all connected to because we live in a connected global economy. One other really interesting thing about sea level rise, which can be hard to wrap your head around, but I think kind of points to paying special attention to where you are in the world, is ocean levels don't rise equally around the world. And I don't need to necessarily dig into the details, and it's counterintuitive, but the people living in Greenland, they are actually having to deal with lowering sea levels. I know that's counterintuitive. So people in Greenland close to the ice loss, they are seeing newly exposed land. That's in stark contrast, for example, from people in the US, for example, along the Gulf of Mexico and along the eastern seaboard, who are going to see more sea level rise than the global average. So there are communities in Louisiana and Florida and areas like that that are going to see very substantial levels of sea level rise compared to other communities. And that's going to take extra adjustment and planning.
Well, that was a very thoughtful answer. So I wanted to give you a chance here to for a one-word answer that is asking you to make a judgment call here. Does the loss of sea ice for the Earth, is that a good thing or a bad thing?
It's a bad thing.
Okay. So, well, easy. Okay. Next, we have a question, and I'm not sure that I'm understanding this question correctly, but it's about sea ice creep and its effects on ocean wave dissipation. Do you have any thoughts about those two variables, modeling the sea ice movement and what that would do to ocean waves?
Yeah, so I want to start out by making sure that people have in their mind the difference between land ice and sea ice. So Greenland is land ice. All of the ice in Greenland is formed from snow that is falling on the land and then piling up and staying put. So all of the ice in Greenland sits on land, even if that land is below sea level underneath it, and it's all fresh water. That's in stark contrast to sea ice, which is what we see forming across the Arctic Ocean along the North Pole. And sea ice is forming directly from the ocean surface water. And so when we're asking questions about waves, we're asking questions about sea ice. And sea ice is another area where we've seen really dramatic losses in the Arctic. All of the lowest extents of sea ice in the last the last 14 years have been the 14 years of record low sea ice. So we don't have as much sea ice in the Arctic as we did before. And just as this question suggests, when you have a sea ice on the surface of your ocean, if you're trying to push waves through it, that sea ice kind of helps to dampen those waves. It's harder for this wave to keep doing that because the sea ice kind of wants to slow it down. And so one thing that we see happening in the Arctic is coastal communities don't have as much sea ice near them. And so the waves that come with big storms are coming right up to the coast, and that creates more coastal erosion than when we had sea ice there. So that is a problem. Sea ice really helps with dampening the influences of waves and storms, and without it, communities do see more storm damage.
Awesome. Thank you for helping clear that up. That totally makes sense. And I think I'm gonna ask one more question if I have good enough internet. I'm getting a bad network sign, but let me see. The last question is about the sort of benefits to the world and society of Greenland's ice. And I know you've talked about several of these. Anything else that you didn't yet have a chance to speak to that you wanted to make one more plug for why we should be preserving Greenland's ice sheet for the benefit of everybody?
Yeah, well, and I'd like to expand it to thinking about why we should be preserving ice anywhere on the globe, because ice in different places provides different services. So any land ice around the globe is helping to kind of keep ice on land and keep that water out of the ocean. Greenland and Antarctica are, of course, holding most of the ice. But people in Greenland, but also people who are near glaciers all around the world, you find that glaciers provide drinking water. Glaciers provide water that's important for agriculture. There are some places where melt from glaciers is used for hydropower, so people are getting electricity from glaciers. And there are other things. For example, as you have glacial melt travel into a river, it can help keep that stream or river colder temperatures and keep it the right kind of ecosystem for fish or other living things in it. So there are a lot of really important things that not just ice in Greenland is doing for us, but ice around the globe is doing for us that we want to make sure it's still there to do. The cool thing about taking action that's going to help keep ice in Greenland is that many of the different hazards that are caused by climate change, so well, all of the hazards caused by climate change really, that range from more wildfires to more intense storms to more flooding, all of those are caused by this one fundamental thing, climate change. And we scientists have a really good understanding of why we're changing the climate. We're putting carbon dioxide and methane into the atmosphere, and we're changing the surface of the earth. And because we understand so well why we're creating those changes, we also understand super well what changes we need to make to pull back some of those changes. And if we address one problem, we actually address all of the problems. So that's kind of a magical thing about climate change that is unique, is you can take action that is going to help keep ice in Greenland. It's also simultaneously going to help us not have as many floods or droughts or wildfires and better food availability and things like that. So that's a pretty unique kind of problem.
What a great note to end on. Dr. Twila Moon, thank you so much for being with us today. And we just are so grateful for your time and your knowledge and for sharing it with us.
Yeah.
And so if folks want to connect with you, I guess you can contact us through the Science at Home website, and we can get your questions that you didn't have a chance to ask passed on. It looks like we've got one more question I can see that maybe will work for next time Science at Home. We'll have Walt Meyer is going to speak to us about sea ice. So sort of the flip side of this, continuing on our understanding of the cryosphere. So again, thank you so much, Twila, and thanks everyone for joining us, and we'll see you next time.